Alright, hello everyone. I did section 5.3, question 83, and what they ask us is to prove how a reduction formula will work for the sine, cosine, and tangent functions here, where the reduction formula is actually going to reduce the amount of terms that you have in order to simplify the equation. And to prove this, we'll start out by prefacing some basic geometry with the circumference of a circle being 2 pi times r, where the radius of any unit circle by definition is 1. So we can actually eliminate the r. There's no point in having it in there where it's just 1. So the actual circumference of a unit circle is 2 pi, and that's where that comes from. So all the way around the circle is 2 pi, so pi is actually halfway around any point in the circle. You start at one point, you add pi to that, you end up halfway around that circle. And so to prove that for sine t plus pi is equal to negative sine t, basically what we would have to do is for any point t, wherever you end up, you would actually go to the opposite quadrant over here. If you start out in quadrant 1, you're going to end up in quadrant 3. And again, by the quadrant definitions, here in quadrant 1, you're all positive. So if you come around to quadrant 3, you're on the negative side of the x-axis and the negative part of the y-axis. So that, by going from the positive, you swing around and those points are negative, because sine is the value, the sine t is the value of the y coordinate by definition again. So if you took the negative of your point here, then you're going to have a negative y value here because you're in the negative part of that y-axis. And that goes, the same actually goes for cosine as well, because the cosine of t is the x value. So if you start out with the positive x value, you go to the opposite quadrant and you have the negative x value. But the same applies if you start in quadrant 2 and you have a negative x value, you swing halfway around that circle, you're in the positive part of the x-axis. And again, same with sine. If you did sine t plus any point t in quadrant 2, you start out with a positive y value, swing around pi halfway around the circle, and you're in the negative section of your y-axis. So that is why sine t plus pi is equivalent to negative sine t, because at any point, whether you have positive or negative, it's going to, the sine of t plus pi is going to be equivalent to the negative of just sine t. Now for tangent, tangent's a little bit different because tangent is an actual ratio. The ratio of, I believe it's y over x is your tangent t. So with that, you have the properties of quotients that apply here. So if you have all positive values here, if you add pi to that value, you swing around to here, both your x and your y is negative. So because that's a ratio, if you have two negatives, you automatically, when you divide a negative by a negative, you get a positive. So that is why tangent t plus pi is equivalent to tangent t. The same would apply if you're in these other quadrants here. If you have a negative and a positive, you swing around here, you're going to have another negative and a positive, and so there you'll have a negative tangent value. So if you do tangent t plus pi out of here, you'll have a negative value. You swing around here, you'll have that same negative value when you swing around to this side of the quadrant. So that is why this proves that these can be reduced to these particular expressions here. Okay, thank you.